I'm gonna answer the two questions you have right now. 1, James, why do you have a mustache? Because I feel like it. 2, how do social networks know what content and friends to suggest to me? We're gonna talk about all that, excluding the mustache, and build a suggestion algorithm in just a few minutes. So let's talk about some use cases for suggestion algorithms. One that maybe not many of you are very familiar with nowadays is Facebook friend suggestions. Facebook uses mutual connections, so people that you know that know somebody else, to suggest people you may know to you. We've discussed this previously in a video, but basically they use this second degree of connection to say, hey, you might know this person, you should probably add them. Another one that many of you will be very familiar with is, of course, YouTube. YouTube uses suggestion algorithms to look at your interests and videos you've watched to suggest new videos and new channels for you to check out. They also look at people that have similar interests to you and look at what they're watching, and they use that data to then suggest it to you to hopefully see if it's a match or not, and then slowly refine their suggestion algorithm over time. TikTok uses a very similar algorithm to this. I've also used suggestion algorithms in projects of my own. One of them was a friend finder for my university, and we used the same mutual connections feature as Facebook. We also use suggestions based off of interests that you may have, so things you're interested in, classes you attend, what year of study you're in, what hobbies you have, things like that. Another one was a B2B, that's business to business, suggestion algorithm for suggesting shoes for businesses to purchase wholesale from Adidas. So it would compare places like Foot Locker to Sport Chek if you're Canadian, and it would say, hey, Sport Chek is buying a lot of these shoes, maybe Foot Locker should try to buy some of those as well, because they appeal to the same crowds of people and they're in the same malls, they're in the same areas, and they just have a lot of similarities. The whole point for suggestion algorithms is finding those unique points and figuring out what their similarities are, and then being able to use those similarities and their actions, their independent actions, to then suggest to the other independent node what they should be doing. It maybe sounds a little confusing, but I assure you it's very simple, and we're gonna break it down and we're gonna build a suggestion algorithm right here, right now. Today we're gonna make a friend suggestion algorithm, and we're gonna do that using a graph database called Neo4j. I've spoken a lot about Neo4j in a previous video called Types of Databases, and you can check that out down below in the description or up above, wherever the I is. I'm not really sure. We'll be using Neo4j first and foremost because I have a lot of personal experience with it, so it's gonna be super easy to write all these queries. Second, it's free, so you guys can download it and run it on your personal computers and build the same database, run the same queries, and even experiment beyond this video. And third, Cypher querying language is open right now, and I'm not sure if it's used in other databases yet, but it's pretty intuitive, and I can definitely see it becoming an industry standard, sort of like SQL. So I think it's a pretty valuable graph database to learn and experiment with and play around. We of course already know that graph databases are comprised of nodes and relationships. Nodes are going to be the actual things in the graph that we're querying for or against, and relationships will be what connects those items together. Our graph database is going to comprise of 3 different kinds of nodes. The first one will be user nodes, which is going to represent the people inside of our graph. Next, we're going to have the interests, which will be things that people are interested in or hobbies they have, sports they play, things like that. And then finally, we're going to have location nodes. Locations are going to be places that these people go to. It could be a school, a mall, or something of that nature. Next, of course, we have our relationships. All of our relationships will start with a user node, and it's going to be the relationship that a user has to another node. So that could be friends with, if it's a user to a user, interested in, if it's a user to an interest, or goes to, if it's a user to a location. Once we have all of this inside of a graph with all the relationships connecting our nodes, we're going to be able to query the graph for data points that we otherwise wouldn't have seen if we've just looked at it at face value. So let's build it. So I have the Neo4j browser open, and we're going to start by creating some user nodes. So we're going to start by creating Bob. So what we're going to do is we're going to create a simple user node just like that. Now we will see the user node by just typing this, and there we go. That's Bob. So now that we have Bob, we need to add some people for Bob to meet, go to the same place, be interested in the same things. So what we're going to do is we're going to create Alice, and maybe we'll create Ken, Sally, Justin. Let's create Janice as well. There we go. Okay, so now if we match all of our users by returning that same thing, we see we have Sally, Justin, Ken, Janice, Bob, and Alice all right there. Okay, so now that we have all our users, what we're going to do is we're going to add friend connections between these people. So we are going to be adding that relationship, friends with, I mentioned before, and we're going to just start connecting some of these people just across the board. So what we're going to do first is we are going to make Bob and Alice friends with each other. So what we're going to start with is we're going to write a match query for Bob. So we're going to say match a user where their name is Bob. Gotta get the capitals right. There we go. Beautiful. So now I've started a new line, and what I'm doing is I'm matching the second user, which is going to be Alice. So we're going to write, Alice, just like that. So now we have both Bob and Alice matched in our query, and what we're going to do is we are going to create a relationship between Bob and Alice, starting with Bob, and the relationship is going to be friends with, and it's going to end with Alice. Now, you also want to add the same relationship, friends with, going from Alice to Bob. And the reason you want to do that is you want to be able to query this friends with relationship both directions. Now in Neo4j you can add dual directional relationships, but it's convention to just do a singular direction. So what we're going to do is we're going to create two different relationships, friends with, one going from Bob to Alice and one from Alice to Bob. So once we have that, we just execute that. And now what we can do is we can run our match query, match user, user return you. And there we go. We see Bob is friends with Alice and Alice is friends with Bob. So we're going to do this a couple more times for everybody else, and we're going to just make a little community of friends. Now that we've created all those relationships, we're going to return all of our users, and we're going to see that we have a little network of friends. We have Sally's friends with Alice, Justin is friends with Sally. We got the whole thing going on here. So what we're going to do now is we're going to leverage these relationships in a query to see who we could suggest for certain people. So to do this, we're going to start with Sally. So we're going to write a simple command, match u1 user where u1 name is Sally. Ideally, if you're doing this in a production system, you're going to want your identifier not to be a name. You're going to want it to be a user ID, because obviously there's a lot more than one Sally in this world. So you're going to want some unique identifier that you're going to have. But for the purposes of this, it's Sally. So now that we have Sally in our context of our query, what we're going to do is we're going to match u1 where u1 is friends with some other person, some other user that is friends with somebody else. So now we have u2 user. And what we're going to do is we're going to say where u1 is not u2. So that's basically making sure that we're not going to return Sally as a suggestion for Sally, because that makes no sense. Now we're going to return our u2, and we should have a result. There we go. We have Janice and Bob. And if we look back at our graph over here, we could see that Sally is friends with Alice, who's friends with Bob. That's good. And Sally is friends with Ken, who is friends with Janice. Perfect. You can also see Sally's friends with Justin, who is friends with Bob as well. That's fantastic. It comes up for Alice and Justin. So we have our two relationships. And what you could do is you could weight this later on, and you could say, well, Sally probably knows Bob pretty well because Alice and Justin are friends of Sally, and they're also friends of Bob. And 2 is greater than 1 relationship. So they probably know Bob. We can suggest that higher than Janice, let's say. But that's something that you could build into your query later on. For the purposes of this, we have a successful query run. Now you could do this for all the rest of the users, but we're going to move on and we're going to start creating our interest now. What we're going to do is we're going to create our first interest, and our interest is going to be type, and we're going to call it soccer. Simple enough. Execute, and we've created our first interest. So let's check out our interest now. We have match interest return I. There we go. We have soccer right there. So let's create a few more and let's start adding them to our network. So you can see I've added 3 more. I've added Minecraft, swimming, and programming, as well as soccer, which you saw. And let's start connecting these to some of the users inside of our graph. So we're going to start with our first user. We're going to do user where u1.name is Alice. And we are going to match Alice with our interest of soccer. So where I type is soccer. We are going to create a interested in relationship between Alice and our soccer. And we execute that. And now if we return all the nodes, so we don't specify a label, we are going to see that Alice likes soccer. So far she's the only one that likes soccer, but we're going to add a few more and we're going to populate this a little bit. Okay, so I'm going to rerun our command to return all the nodes inside of our graph, and we will see that I've connected a lot more of these interests to people. So there you go, we have a couple shared interests between people. Let's see how we can leverage that inside of a query. So we're going to start with Ken. We're going to do our usual u.name, Ken. We captured Ken inside of our context. Then what we're going to do is we're going to take Ken, and we're not going to specify an interest that we want to try to find. What we're going to do is we're just going to say, what is an interest that Ken has? So we get the label that somebody else also has. So let's see. We just do this and we get U2, and it has to be a user. Obviously it's going to be a user inside of our graph, but if you have a much larger graph databases with more nodes, you're going to want to specify all the labels, which is why I'm doing that in this. Then what we'll do is we will say where u1 does not equal u2, we're going to return all of the user nodes that fulfill that, and we can see that Janice fulfills that. So let's look back at our graph and let's figure out what Ken likes that Janice likes as well. So we have Janice right here, and we can see that Janice is interested in swimming with Justin, so that's not it. Janice is interested in Minecraft, which Ken is also interested in. So there you go, we have a shared interest. We can suggest that person to Ken, and maybe they'll get along with that person. Of course, you could run this again. So if I click this and I just change our name to Janice, let's say, we can see that Janice was suggested Ken and Justin. Now, we already know that Ken and Janice both like Minecraft, and that's why for Janice, Ken was suggested. But let's see why Justin was suggested. So if we go to Janice, we have swimming as an interest, which is then connected to Justin. Perfect. So you can obviously build this out a lot, and the more interest that somebody shares with somebody else, you can rank them higher inside of the suggestions. You can do that all within Cypher, which is fantastic. So let's expand this out a little bit and let's add our location nodes. So I'm going to create our first location, create location, and we're going to give it place as a property, and we're going to call it ABC University. And we're going to create that. And if we just quickly return our locations, we're going to see that we have ABC University. So we're going to create a few more of these, and we'll check out our graph in a second. So now if we take all of our locations and we return them, we're going to see that we now have a few more. We have Google Campus number 18, Coding Bootcamp, of course ABC University, Gardens Mall, and Apple Grocery. So if we look at it in the context of our entire graph and all of our nodes, we're going to see that these are kind of just floating around and they're not really connected to anything. So let's start adding those relationships now. We're going to start with Bob. Bob goes to ABC University. I don't know what he's studying, but something. and I'm sure it's very important. Match location, and we're going to say where L dot place is equal to ABC University. Once again, you would use an identifier for these locations and these users, but for the purposes of this, just names. So we have that, and what we're going to do is we're going to create a connection, a relationship between Bob and ABC University. We're going to say goes to and our location, and we're going to execute that. Done. And if we return our nodes again, we're going to see that Bob goes to ABC University. I'll zoom in a little bit so you can check that out. Bob goes to ABC University. Perfect. So we're going to add a few more of these relationships, and then we're going to check out the graph again in a second. So I've added a bunch more relationships between users and the locations. So what we're going to do now is we're just going to return the network of nodes, and we're going to check out what we have. So we can see Sally goes to Coding Bootcamp, also goes to Google Campus, where Ken also goes to. Alice goes to Apple Grocery. Ken does as well. Bob goes to ABC University. Ken goes to Gardens Mall. We have a few relationships in here that we can now leverage for a query. So what we're going to do is very similar to what we did for our interests, and we're going to see where Ken goes. So we're going to say match user where name is Ken, and we're going to match Ken with the relationship of goes to specifically a location node that somebody else also goes to. So we're gonna effectively have this. We're gonna return, oh, of course we have to say where U1 does not equal U2, and now we need to return U2. And here we go. So we can see that Ken shares some location with Sally and Alice. So if we go back to our graph down here, we could see, so we have Ken goes to the Google campus where Sally goes as well. Perfect. Ken also goes to Apple Grocery where Alice goes to, and that's it. We could see that Ken also has a relationship of going to the Gardens Mall, but nobody else shares that. So of course, it won't connect any other user nodes to Ken for that purpose. Now, obviously, there's a lot more that you could do with this. You could start adding the friends with, the shared interests, and locations all into one massive query. You could start weighting the results, and you could say, well, mutual friends is worth more than somebody that goes to the same university as somebody else. But the options are really all up to you, and there's a lot that you can do with this. You can set your own scores, and there's a lot. You can add more relationships. I could go on forever, and you could tell I'm kind of rambling now, but this is really, really powerful, and this is exactly how Facebook and YouTube and TikTok and all these other social networks connect you with topics or interests or content that they think that you are going to like. So as you can see, it's pretty easy to build these suggestion algorithms, and obviously companies like Google and ByteDance, that's TikTok's parent company, are going to be doing a lot more complex suggestion algorithms, a lot of them using machine learning and taking in a lot of inputs that you or I haven't even thought of or considered. You really could go a whole bunch of different places, and it's really, really interesting to start looking into this and seeing what kind of information these websites can capture to really get a distinct picture of who you are and who you're similar to and what you may like based off of that. I'll be putting all this work that we did today onto GitHub, and I'll be linking it below along with my Adidas demo if you really want to check it out to see that shoe suggestion algorithm that I was talking about in more of like a productized, nice wrapper using Spring Boot, React, and of course Neo4j. And that's about it. Hopefully you guys have gotten a little bit of a taste of what suggestion algorithms are, and maybe you can start noticing them in the wild. If you guys like these kinds of videos, please subscribe and give it a like. I really appreciate it. It helps me a lot. And I'll see you in the next one. Ciao.